Hello everyone, welcome to Robert Morris University Math 0900 Chapter 9, Lesson 4. This is Brianne Pernick. In this lesson we are going to continue our knowledge of working with radical expressions, and we are going to focus on multiplying a monomial radical expression, multiplying a monomial radical expression by a polynomial, and multiplying two polynomial radical expressions. There are no new vocabulary terms in this section. I do need you to recall the basic rule for multiplying square roots, the square root of radicals. We'll say it that way. Please recall that if we are multiplying root A times root B, we are allowed to combine what's underneath those radicals into one. We're still going to use this concept as we work through this lesson. And please note that the direction multiply means to express the product in simplest form as we're working through these problems. So the first example that we have here is root 7 times root 14x. As we're working through this, we want to use that rule of the multiplication of radicals that we just mentioned, and we want to combine the 7 times 14 under one radical. So let's go ahead and take care of that. 7 times 14 is going to make the square root of 98 times x. Remember, all we've done so far is do 7 times 14 and combine that all underneath one radical. At this point, you have to rely on your knowledge of square roots, and it might be useful to pull out that chart that I asked you to make a few lessons back and look for a perfect square that will divide perfectly into 98. And it just so happens that 49 times 2 will make 98. So we're going to go ahead and break 98 into 49 times 2x. We have not changed the value underneath that radical at all. We're just simply splitting 98 into factors that multiply to it, one of which happens to be a perfect square. We can now evaluate the square root of 49. The square root of 49 makes 7, and that's going to leave us with just 2x underneath the radical. And this is going to be our final answer for this problem. We can go no further because we don't know the value of we don't know the value of x, and 2 is not a perfect square. So we're just simply going to go ahead and stop right there. Why don't you try student practice number 1 for me? Go ahead and pause the recording, try this example, and when you're ready, hit play and we'll go over the answer together. Okay, by now everyone should have had an opportunity to complete this problem here. When you combine these two radicals into one, you're going to use that multiplication rule that allows us to multiply the 3a times the 6a and put them underneath one radical. So 3 times 6 makes 18, and a times a makes a squared. At this point, we want to try to break our 18 into factors that will multiply to 18, but we want one of them to be a perfect square. So if we do 9 times 2 times a squared, that shows us that the 9 is a perfect square. And we also know that any time a variable has an even power, that is also a perfect square. So we can take the square root of 9, that is 3, And when I take the square root of a squared, we take the power that's even, divide it by 2, and we're going to get a to the first power. And that's going to leave us with a square root of 2 underneath the radical. So our final answer is 3a square root 2. We have some more examples here that we can take a look at. These ones have coefficients on the outside of the radical as well as radicands underneath the radical. So the way that we want to go ahead and approach this is by multiplying the coefficients and by multiplying the radicands. So 2 times 5 is going to make 10, and 3 times 7 is going to make 21 underneath the radical. Always check to see if you can break your radicand into any type of perfect square. In this particular problem, we cannot, so our final answer here is going to be 10 times square root 21. And we would just simply leave it like that. Letter B. We want to start by multiplying the coefficients of 2a times 3a, which is going to give us 6a. And then we want to move on to multiply what's underneath the radical. We have 3a times 6a, which is going to give us 18a squared. We know from our previous example that that is going to simplify to 3a square root 2. We just did that one. Now, I separated that on purpose with a parenthesis because I want to point out to you that when you have a coefficient and you are factoring out that square root and evaluating that square root, you must multiply your coefficient and the square root that you have evaluated. So we now have to multiply 6a and 3a to get 18a squared times the square root of 2. And this is our final answer right there. I would like you to take a moment and complete student practice A and B, and as soon as you're ready, we will go ahead and go over the answers. Okay, by now you should have had an opportunity to complete examples A and B, and you should be ready to check your answers with me. For example A, you want to start by multiplying the coefficients of 2 and 5. 2 times 5 makes 10, and then we're going to move on to multiply our radicands. 3 times 5 makes 15. Underneath your radical, you always want to check to see if you can break that radicand into a factor that is a perfect square. 15 cannot be broken up, so you're simply going to leave your answer as 10 times root 15. For example B, we're going to follow the same process. We're going to start by multiplying the coefficients out front. So 4 times 2x makes 8x. And then we're going to multiply the radicands underneath the radical. 3x times 6x gives us 18x squared. We're going to bring down the 8x, and we want to try to break that 18 into some type of factor that is a perfect square and something else that will still multiply to 18. So we can break that into 9 times 2 times x squared. And now what we want to do is take the square root of the perfect squares. So I'm going to bring down my 8x, throw in a parenthesis so that I remember that I'm going to have to multiply my coefficient by the perfect squares that I evaluate. The square root of 9 is 3. The square root of x squared is x. And that's going to leave me with a square root of 2 underneath the radical. Now I must multiply my coefficient of 8x times 3x, which gives me 24x squared times the square root of 2 as my final answer. Example 3 is a real-world example that tells us that the area of a farm measures square root 9,400 feet long and square root 4,800 feet wide. Express your answer, or they're asking us to find the area, my apologies, and they want us to express the answer as a simplified radical. So keep in mind that when we're finding the area, we're going to use the formula length times width. So we'll start by using square root 9,400 times square root 4,800. As you are evaluating this problem, before you go any further, it's probably going to be easiest for you to think about this as terms of 94 times 100 times 48 times 100. The reason that I suggest that is because 100 is a perfect square. Right off the bat, we can evaluate that square root and we get 10 times root 94 and 10 times root 48. From here, you might look at that and say, well, 48 has a factor. Oh, I wrote 48 as I was saying it. Let me get that out of there real quick. 48 has a factor as well that will break into a perfect square. We can multiply 48 as 16 times 3. So you can break that square root into 16 times 3 underneath that radical, which will allow you to take the square root of 16, which is 4, multiply it by 10, and have 40 square root 3. You have now simplified those very large length times widths, and you can now multiply the coefficients and what's underneath the radical to make a smaller, simplified answer before you have done any of the work. If you had started by multiplying 9,400 times 4,800, it would have been very difficult for you to simplify that radical. But if you simplify it first and then use the multiplication rule, it has now become much easier for you to ensure that you have the final correct answer. So we simply have to do 10 times 40, which is 400, and 94 times 3, which is 282, and that is area, so that is square feet. So again, the reason that we broke down the length and width first was to make sure that we had the finalized radical as our answer, because it was easier to break down the length and width while they were in their length form and width form than it would have been had we chosen to multiply first and then try to factor out those square roots. I would like for you to try student practice number 3. Please pause the recording, and as soon as you are ready, we can go ahead and move forward. Okay, by now you should have had an opportunity to complete student practice number 3. Again, we're working with the area formula, so we want to start out with length times width. So we're going to plug in our square root 180 and multiply that by our square root 150. Now, as I mentioned in the previous problem, we can go ahead and apply the multiplication rule right now and multiply our 180 times our 150. However, that would probably make our multiplication much more complicated as we try to find our square root, because I doubt that we would, off the top of our heads, know what the square root of 27,000 is. But as we're looking at this and we break apart the radicals now, we might see that 180 can break into 36 times 5, and 150 can break into 25 times 6. So we do have a perfect square that will go into both of those numbers. So evaluating the square root of those perfect squares, we're left with 6 times root 5 and 5 times root 6. And then simplifying that area, we're left with 30 root 30, and that is millimeters squared. We're now going to move on to the next topic, which is multiplying a monomial radical expression by a polynomial. So I do need you to remember that a binomial consists of two terms. So when you see the expression root 2 plus root 5, that's a binomial. You have two terms that are being added together. If you look at example 4, we have to use the distributive property to simplify this example. We have the monomial root 5 that's being multiplied to the binomial square root 2 plus 3 times root 7. We're going to use all of the same properties and methods that we have learned previously to simplify this problem, and then integrate in what we have just learned about radical expressions. So let's take a look at how we'll do example 4. We're going to distribute, as I mentioned, the root 5 in. And when we do so, root 5 times root 2 will make root 10. We're simply going to multiply what's underneath the radical. Then we multiply the coefficients. 1 times 3 is 3. And then we multiply the radicands. 5 times 7 makes root 35. We check for like radicals. We don't have any. So at this point, we have to stop right where we are. And that is our final answer. I would like for you to go ahead and complete student practice 4. Please pause the recording, and as soon as you are ready, we will move forward and check your work. Okay, by now you should have had an opportunity to complete student practice 4, and you should have started by distributing in root 6. Root 6 times root 3 makes root 18, and root 6 times 2 root 8 makes 2 root 48. At this point, we want to try to see if we can break our radicands into any factor that contains a perfect square. 18 can be broken into 9 times 2, and 48 can be broken into 16 times 3. And now we're ready to evaluate those perfect squares. The square root of 9 is 3, so we bump that out front and leave the 2 inside the radical. The square root of 16 is 4, so that bumps out front and multiplies by that 2. So 2 times 4 makes 8. The 3 stays underneath the radical. And this is our final answer. We have also discussed in the past that problems such as root 5 times root 5 has simply made 5. Reason being that root 5 times root 5 made root 25, which is a perfect square. So that gets us right back to the 5. Root 3 times root 3 is equivalent to 3. Think about the logic. 3 times 3 is 9. Square root of 9 is 3. Okay? These are specific cases of where the multiplication rule where there's a multiplication rule for these. When you are multiplying the same number underneath a radical by itself for any non-negative real number, you will always get that number that's underneath your radical. Always. If you think logically about what's happening when you are doing that multiplication, you are always creating a perfect square underneath that radical. Therefore, you will always be able to evaluate that perfect square and simply get back to the number that is underneath the radical, which is your radicand. So let's go ahead and practice an example of how this works. We have square root a times 3 square root a. Using that rule, we should see that root a times root a is simply going to multiply to a, and we can just write 3a. And then we'll distribute into this term and have root a times negative 2 root 5, and this will make negative 2 root 5a. Now, if you happen to forget about this rule and you were to write it as 3 square root a squared minus 2 square root 5a, and then say, hey, a squared is a perfect square, I can evaluate that, you would get right back to 3a minus 2 root 5a. You still get the same answer. It's okay. It's just a shortcut that teaches us that we are permitted to use that rule because we're creating a perfect square underneath that radical. So it'll just save you some time and some heartache if you memorize that rule. I'd like you to go ahead and try student practice number 5. Please go ahead and pause the recording. Press play as soon as you're ready to go over your answer. Okay, by now everyone should be ready to go over the answer for this problem. So the first thing that you want to do is start by distributing in the 2 root x. So 2 root x times 4 root x. 2 times 4 makes 8. Root x times root x makes x. Then we're going to distribute 2 root x to negative x root 2. 2 times negative x makes negative 2x. Root x times root 2 makes root 2x. At this point, your problem is simplified. Again, if you started this problem out and said 2 times 4 is 8, root x times root x is x squared, and then completed the rest of the problem from there, you're fine because you will still recognize that x squared is a perfect square, and you'll simplify that, and you'll continue down on your way, and you'll get the same answer. It just saves us time and saves us a step to recognize that that is a perfect square. The next topic that we're going to work on is the topic of multiplying 2 polynomial radical expressions. Excuse me. And this is going to require us to use the FOIL method that we learned in our last lesson. So in our last lesson, we dealt only with algebraic expressions such as 2x plus y times x minus 2y. we learned to use the first times the first, the outer times the outer, the inner times the inner, and the last times the last, and then to simplify our expression from there. Using radical expressions, we will use exactly the same method. We are still going to FOIL. The only difference is that we will be using radicals. Okay, so we're going to do our firsts times our first. We have 2 root 3 times root 3. So 2 root 3 times root 3 is going to give me 2 times 3. That represented my first. Now I'm going to move on to my outers. I have 2 root 3 times negative 2 root 5. That's going to give me negative 4 root 15. Now I'm going to move on to my inners. I have root 5 times root 3, which is going to give me positive root 15. That's my inner. And then I'm going to move on to my lasts. I have root 5 times negative 2 root 5. So I have negative 2 times 5. That's my lasts. From here, I'm going to simplify what I got for my firsts. That should give me a 6 minus 4 square root 15 plus square root 15 minus 10. And now I want to combine like terms with my square root 15s. So negative 4 plus 1 is going to give me negative 3 square root 15. And then I can look and see that I have 2 constant terms that do not have a radical that I can combine. I have 6 minus 10. So that is negative 4 minus 3 square root 15. That is the method that we're going to use in order to solve and simplify radical expressions. Please keep in mind that if it's hard for you to use the simplification that I did right there, as well as right here, it is okay, and you could have multiplied that and made it root 9 and root 25, and that would have been acceptable, and you could have simplified from there. Okay, it's perfectly fine. Let's look at another example. Let's start example 6. We do have 2 binomials that have to be multiplied. So first times first, we have root 2 times root 2, which is just 2. Remember, that's like the square root of 4, which is 2. Then we're going to do our lasts. Square root of 2 times negative 3 is negative 3 square root 2. Then we move on to our inners. We have 5 times root 2, and then we have our lasts, which is negative 15. We're going to combine like terms. 2 minus 15 is negative 13. And then we're going to combine our like radicals. Negative 3 plus 5 is 2 root 2. And this right here is our final answer. That is as far as we can go. I would like for you to complete Student Practice 6. Please go ahead and try Student Practice 6. Please pause the recording. As soon as you're ready, please press play and we'll move on from there. Okay, at this point, you should be ready to go over the answers for student practice number 6. The first thing that you should have done here is multiply root 2 times 2 root 2. That's going to give us 2 times root 4, or just 2 times 2. So I'm going to put an F here so we remember that we got that there in our first step. Then we're going to move on and continue our foiling and do our outers. We have root 2 times negative root 6, which is going to give us negative root 12. Moving on, we're going to do our inners, and we have root 6 times 2 root 2, which is going to give us positive 2 root 12. Lastly, we have root 6 times negative root 6, which gives us negative root 36. We're going to go ahead and simplify in the next step. 2 times 2 is 4. Negative root 12 plus 2 root 12 gives us positive 1 root 12. I'm just going to write that as plus root 12. And then the square root of 36 is just 6, so I'm going to go ahead and write that as minus 6. In the next step, I'm going to continue the simplification process. 4 minus 6 is negative 2 plus, now 12 can be broken into factors that are a perfect square. 4 times 3 makes 12, and 4 is a perfect square. I can now work on evaluating that. The square root of 4 is 2, and that leaves me with a radical of 3. And that is our final answer. Okay. 2 more examples for this section. Let's do, I'm sorry, we have more than 2. Let's do example 7 together, and then you can do student practice 7 on your own. We're going to continue with our foiling. We have root 2 times root 2, which gives us 2. We have root 2 times root 6, which is positive root 12. Negative 3 root 6 times root 2 is negative 3 root 12. And negative 3 root 6 times root 6 is going to give us a negative 3 times 6. As we start the simplification process, I'm going to bring down my 2. We have 1 root 12 minus 3 root 12. So that gives us negative 2 root 12. And negative 3 times 6 is negative 18. Continuing on, 2 minus 18 is negative 16, minus 2 times the square root of 4 times 3, because I want to start to break my 12 into that perfect square. As I evaluate the square root of 4, which is 2, we want to keep in mind that once we bring that square root out, we have to multiply it by that coefficient. So negative 2 times 2 is negative 4, square root 3. And this is our final answer. I would like you to go ahead and try student practice 7. Please pause the recording, and as soon as you're ready, we'll go over the answers together. Okay, by now you should be ready to go over the answer for student practice 7. We're going to go ahead and use the FOIL process here. We're going to start with root 6 times root 2, which gives us root 12. Root 6 times 2 root 5 gives us 2 root 30. Root 5 times root 2 gives us root 10. And then we have root 5 times 2 root 5, which is going to give us 2 times 5 using that product rule that we learned in this lesson. We're going to start the simplification process. I'm going to break my root 12 into root 4 times 3. There is no perfect square that will go into 30. There is no perfect square that will go into 10. And 2 times 5 makes 10, so I can take care of that simplification. The square root of 4 is 2, so I'm going to bump that out front. So I have 2 root 3 plus 2 root 30 plus root 10 plus 10. I have no like radicals, and there is no further simplification that can be done, so at this point my answer is complete. Okay, example 8. Let's see if you can remember what we're supposed to do here. Remember, you have a quantity squared. What should we do when we have a quantity squared? Think about it for a second, jot it down on your paper, and then we'll see if we have that right. When we have a quantity that is being squared, please remember that you have to break that into the repetition of the quantities that matches the exponent. So since we have an exponent of 2, we have to write our quantity 2 times. So we're going to have 2 root 3 minus root 6 times 2 root 3 minus root 6. This does create a binomial times a binomial. I would like for you to go ahead and start this problem. Please complete it and press play as soon as you are ready to check your answer. Okay, by now you should be ready to check your answer. I am going to solve this one. We're going to do it exactly the same way, but instead of using the product rule that we have been using throughout the lesson, I'm going to show it in case someone prefers to use it multiplying the radicals and then simplifying, just to show it a different way for some of you. Okay, so we have 2 root 3 times 2 root 3. We could write that as 4 root 9. Multiplying my outers, we have 2 root 3 times negative root 6. That's going to make negative 2 root 18. Multiplying my inners, I have negative root 6 times 2 root 3. That is going to make negative 2 root 18. And lastly, I have negative root 6 times negative root 6. That's going to make a positive 36. So please note in this line here, I'm going to pause, that the other examples I've shown, I used the product rule, and instead of writing root 9, I wrote 4 times 3. Instead of writing plus root 36, I wrote plus 6. You have an option here to do whichever way you like better. It's up to you. I want to show it both ways. Okay, continuing on, we're going to go ahead and start the simplification process. The first thing I see here is that I need to evaluate my square root of 9. So 4 times, the square root of 9 is 3. 4 times 3 makes 12. I have negative 2 root 18 minus 2 root 18, which makes 4 square root 18. And then the square root of 36 is 6, so I'll write plus 6. We can simplify more by breaking the 18 into a 9 times 2 and bring down the positive 6. As we take the square root of 9, please remember that we must multiply it by that negative 4 out front. So negative 4 times 3 is negative 12 root 2 plus 6. And the last thing that we need to do here is add the 12 and the 6. We could have done that several steps back if you wanted. 12 plus 6 makes 18. It actually would have made sense to do it way back there, because then we wouldn't have had to keep writing it over and over. Move my little example back down where it goes. Okay, so our final answer is 18 minus 12 root 2. 18 minus 12 root 2. We have one more example here, student practice 8. This is our last example for this section. I would like you to take a moment, complete the example, and as soon as you're ready, press play and we will go over the answer together. Okay, by now you should have had an opportunity to complete student practice 8. The first thing that you would want to do here is rewrite this as a quantity times itself. So we'll have 3 root 5 minus root 10 times 3 root 5 minus 10. The reason that we have to write quantity times quantity is because we originally had quantity squared. So we do need to break that up into two quantities being multiplied by each other. Now we will use the FOIL process. 3 root 5 times 3 root 5 makes 9 root 25. Now we'll do the outers. 3 root 5 times root 10 makes negative 3 root 50. Inners, negative 10 times 3 root 5 makes negative 3 root 50. Negative root 10 times negative root 10 makes positive root 100. Starting the simplification process, the square root of 25 is 5. So we will have 9 times 5 minus, we can combine our negative 3 root 50s. Negative 3 root 50 minus 3 root 50 is negative 6 root 50. And the square root of 100 is 10. 9 times 5 is 45 minus 6 times, the square root of 50 can be broken into 25 times 2. And then I'll bring down my plus 10. 45 plus 10 is 55. The square root of 25 is 5. When we bump that out, it gets multiplied by the negative 6. Negative 6 times 5 is negative 30, root 2. And here is our final answer. If you have any questions at all about anything that we did in this section, please feel free to contact me. I will be more than happy to set up a time to work with you to make sure that you understand everything that we've done. Thank you.